Greetings, everyone. Today we are going to work on the general form of a circle and an ellipse. So it's almost like we're starting over with our conics. And general form. Did you know that if we expand the equations we've been using, like we FOIL, we multiply, we distribute, right? If we simplify things, our equations can look way different. And so we're going to work on how can I write something that looks different in a way that I understand. And part of that process is going to be remembering how to complete the square. All right, we do have a foldable for this, so make sure you're in the process or have that out and ready. And let's talk about this. The equation of any conic can be written in this form. And this is called a general second degree equation, meaning you'll likely have two exponents that are 2. It's still our highest exponent, so we do say second degree. But if I'm given an equation like that, I have no idea how to graph that, right? So we need to transform it into something we do know how to graph. All right, let's talk about the equation of a circle. Now, that top equation, I know that's a circle. Quantity squared equals radius squared. I could graph that easily. If I look at the bottom equation, that's what would happen if I multiplied the top equation out. If I, for example, wrote this for distribution's sake, and I wrote this for distribution's sake, multiply that out, move the 16 over. I mean, I could just quickly bust this out, right? Move that 16 over. That's how that negative 11 came to be. So we can do that, but our goal today is, first of all, we got to work on identifying which type of conic it is, and then we want to take this equation and transform it into something we can actually use. So how do we know it's a circle versus an ellipse today? We'll get into that in a moment. Let's talk about an ellipse. Quick refresher. An ellipse is quantity squared. I can tell my vertex. It's always equal to 1, and we always have denominators, right? We have, possibly we had to make those denominators by simplifying, but we have factors. I'm going to think of those denominators as factors. And so when I look at this equation, I see an x squared plus a y squared, and I see a factor. Okay. Now I could multiply to get there, but our goal today is to go this way. So how do you know which type of conic it is without doing any work? You need to first pay attention to what's being squared, right? In a circle, the x and the y are squared. In an ellipse, the x and the y are squared. In a hyperbola, the x and the y are squared. In a parabola, no. In a parabola, only one value is squared. So I could narrow it down to 3 options. Next, you want to look at the coefficients in front of the squared terms and their signs. And their signs, meaning if I have an addition sign, that's either a circle or an ellipse, right? If it has a positive sign and a coefficient, sorry, that's not what I meant to do, and a coefficient, then it's an ellipse. If it's a plus sign with no coefficients, then it's a circle. What did we have that had both x and y squared and a subtraction sign? A subtraction sign with both things squared would be my hyperbola. So we really have to remember sort of what's the general form of a circle? What's the general form of an ellipse? What's the general form of a hyperbola? The subtraction sign is what's different there. Okay, all these little details of what makes them different are going to help us determine what the equation would give us. So let's really write this out. I know that this is a circle because both of the x and y's are squared. Their coefficients are the same number, 1 and 1. And they're the same sign, right? Meaning positives. I know this equation is an ellipse because both the x and the y are squared. It's addition between them, between the squared values, and the coefficients are different numbers, right? An ellipse needs to be a circle squished. So the numbers, the length and the width should be different, right? Now, what if we want to graph it? Then we need to rewrite that equation to get it into the form that we know best. I do have some steps here written out. Please consider pausing, writing, and then listening. So step 1, you want to group all the x's and the y's. We like to joke and say the boys with the boys, the girls with the girls. You're going to send any constant numbers to the other side of the equal sign, right? If you just have regular numbers, kick them over. Step 2, the coefficient of the x squared and the y squared must be 1. If they're not, we have to factor them out. That's going to take some work. Step 3, take the number before the x, divide it by 2, and square it. Oh, what does that sound like? That's our completing the square steps. We're going to do the same thing for the y. We're completing the square twice. Now, if I add these, not made up, but these new numbers to the left twice, if I add it to the x and add it to the y, then that means we also, step 4, need to add those numbers to the other side of the equation too. Now, a little note. If you factored out a 2, then when you add it to the right side, you need to consider that initial factor that you took out. Okay. What we're doing when we complete the square is we're creating a factorable expression that we're going to work with. I know these steps are a little insane. It'll make more sense when we work it out. So let's jump in. The first thing we're going to do is identify what kind it is, and then we're going to rewrite it. First thing I notice, it's x squared, it's y squared. It's a plus sign. Okay, so it's a circle or ellipse. Today and today only in this video, we're going to stick with that. I have a factor out front. You know what? That tells me that this is an ellipse. Okay. All right, let's jump into rewriting this. First step, group the x's and the y's and move the constants to the other side. So we added 27 over. We wrote the x's together and we wrote the y's together. Now there was only one x, which means, or 1x squared, which means I'm going to fill in a 0x, right? Like I want things to be symmetrical. If I have y squared and y, I want an x squared and an x. If you're missing any piece, use a placeholder of 0. Okay, does that make sense so far? All right, step 2. The coefficient of the x and the x squared must be 1. Well, if this is 36, I need to divide both of these by 36. So I divide it out of 36, which gets me to a 1 and still a 0. The y squared is by itself, so I don't have to worry about that one. Step 3. Take the number in front of the x, divide it by 2, and square it. Take the number in front of x, divide it by 2, and square it. Take the number in front of y, divide it by 2, and square it. Now, do you have to show this work? I don't think so. I think you can calculate that in your head and maybe just jot down the 0 and the 9. Step 4. Add these numbers to both sides of the equation. Let me show you what that looks like. So we took this 0 and we added it in our parentheses. We took this 9 because it was my y value and I added it to my y information. There I am adding it to the left, but I also need to add it to the right. Now let's talk about this 36 here. If I have a factor of 36, I have to multiply it by that value when I add it to the other side, right? Because I need this, I need this and this to match. If I have a 36 with the 0 on the left, I need a 36 with the 0 on the right. I have a 1 with the 9, so I just have a 9 on the right. Okay, that's going to take some practice. It really, really is. All right, we've added them to both sides. Step 5, factor. Now, how this is written, to be honest, I would probably write it with the factor of 36. If I factor x squared plus 0x plus 0, that's actually x plus 0 squared. So if that makes more sense to you, great. The y squared minus 6y plus 9. If I factor it, I get y minus 3 twice. So we write it as twice. All the constants on the right, we just combine them like regular old numbers. Now, I didn't write step 6, but technically we need to tidy this up, right? It's looking so close to what we need. It's looking like a circle, and we want it to be an ellipse, right? We never have sort of this factor out here and another number here. That doesn't make sense, right? If I want it to equal to 1, as we have in the past, I'm going to divide every piece by 36. Remember when we did that with ellipses? So if I do that, I get a denominator of 1, a denominator of 36, and I get my nice clean 1 on the right. I know, this is intense. This is going to take some practice. Let's jump to example 31. First, let's identify the type of conic. Things I notice, I see x squared and y squared and a plus sign. So it's either a circle or an ellipse today. They both have the same factor of 1. Therefore, it's a circle. Now let's go through our steps. Step 1, group the x's and group the y's. All I did was rearrange and move the constants to the other side. So inverse operation. I subtracted the 38 over. Right? That's more of a logistical step. Step 2, the coefficients of x squared and y squared must be 1 or they need to be factored out. Well, perfect, they're already 1. Step 3, take the numbers before the x and before the y, and we want to complete the square, which means we take those numbers, we divide them by 2, and we square them. 16 divided by 2 squared is 64. Negative 2 divided by 2 and square it is 1. Step 4, add those numbers to both sides of the equation. Meaning I'm going to add the 64 right here, I'm going to add the 1 right here, and I'm going to add them both to the right side. There was no factors to worry about multiplying out front, so no special things. It's a regular old 64 and 1 on the right side. Step 5, factor. Now, we completed the square. When you complete the square, you will always factor and get the same thing twice. That's the whole point. I need the same thing twice and the same thing twice. If I don't get that, I don't have a conic. So if you get anything other than x plus 8, then something's wrong. X minus 1, something's wrong. Next, this is a circle, right? I have no extra factors out front, no extra denominators to worry about. I can leave that 27 there because that's my r squared. I need to get it into a form that I can graph based on my previous understanding. Let's try another one, example 32. First, let's identify what we have. I have an x squared, y squared, and a plus sign, which means it's a circle or an ellipse. I have different factors out front, which means my axes are different lengths, which means it's an ellipse. Let's go through our steps. Step 1, group the x's and the y's. Move the constant to the other side. Step 2, the coefficient of the x squared and y squared must be 1, so I need to factor out. So let's see, if I look at my first set, I need to factor out a 9. Even if it doesn't divide pretty, I have to take a 9 out. And let's look at the second set, I have to divide a 4 out. Okay, we want to leave that 9 out front, leave the 4 out front. Step 3, let's complete the square, meaning I need to take this value, divide by 2 and square it. Take this value, divide by 2, and square it. Step 4, I need to add these numbers. So I'm going to add this 25 to the x's. I'm going to add this 1 to the y's. But when I add it to the right side, this 9 and this 25 need to multiply before I add it to the right. This 4 and this 1 need to multiply before I add it to the right. That's the part that's going to take so much practice. So let me show that. I added the 25 to the left. I added the 1 to the left. And look at how this right side looks. 9 times the 25. I don't just add 25 and multiply by 9. I don't just add 1 to the right. It's got a factor of 4. That's going to be the tough step. Maybe put a star by that one. I feel like that's where we're going to spend most of our time or where we're going to make silly mistakes. Step 5, factor. I got x minus 5 times x minus 5, so let's write that out. The 9 just hangs out. I get an x minus 1, so I write that quantity squared with the 4 hanging out. The right side simplified down, so nice and pretty. Now this is an ellipse, which means it needs to be equal to 1. So I'm going to divide everything by 36. When I do that, it simplifies down to a denominator of 4, a denominator of 9, and equal to my nice clean 1. Let's keep going. Number 34. First, let's identify what it is. I have x squared, y squared plus sign with both the same coefficients, so therefore it's a circle. Go through our steps. Step 1, group the x's and the y's and move the constant to the other side. Step 2, the coefficients of x squared and y squared must be 1. Check. Good. It's a circle. It should be. Step 3, complete the square. We want to take negative 12, divide by 2 and square it. We want to take negative 8, divide by 2 and square it. We're going to add this 36. We're going to add this 16. We're also going to add that 36 to the right and add that 16 to the right. So when I add that 36 to the right, to the left, and I add the 16 to the left, we've completed the square, which means those are now factorable. Because I had no leading factor, it's a regular old 36 and 16 on the right. Step 5, factor. A nice clean x minus 6 quantity squared. A nice clean y minus 4 quantity squared equal to 81. Now because this is a circle, I have no factors out front. That's good. It's equal to r squared. That's good. I have what I need to graph my circle. This is going to be one of the toughest topics in this entire unit. There are those systematic steps to walk through. It's just a lot more to remember. So an idea, consider rewatching this without taking notes, right? When you're watching, listening, and writing, you're essentially distracted. So consider narrowing it down to just watching and listening. Please consider that. Make sure you check Google Classroom to see what the task is. We're going to have to spend some time on this. Let me know what questions you have. Let me know if you need to seek out someone in the Sabre Center. Check out other YouTube videos, see if maybe another explanation helps. And until next time, have a good one.